Okay, so in the last tutorial, we went through the USB CDC, we activated, we received some data, and we responded relevant answer. Okay, so now we will go through implementing a Python code for receiving and processing this data. Okay, so let's open Python. Oh, sorry. I'm using PyCharm, which you can also get it from the IntelliJ or JetBrains company. And if you're a student, you can use a free license for the students. This is like a really nice environment for writing codes in Python, and I'm using that for writings. Okay, so what we need to do is that we need to write a code for Python USB serial communication. Okay, so let's see what we have here. So we have PiSerial. Okay, we want that. PiSerial. Okay, does it have any source code to use? Okay, PiSerial. So let's see. The module encapsulates the access to the serial pro backend running on Windows. Okay, that's what we want. Let's start with this python-m. So if you don't have Python installed, just install it, then use this PiSerial to connect to the board. Okay, so let's make a new project. Okay, so let's use this configuration. So we will make a new virtual environment. You can read about the virtual environment later if you want. And then I'm using Python 3.8, and you can do the same, or you can use the latest version. Okay, so let's open in this window. It's creating new virtual environment for us. So virtual environment basically isolate the libraries and the Python version that you're using, so it doesn't interfere with the other project that you have in your PC. So that's what I usually do, but you can use it or you can just skip this. But I would suggest to use it. Okay, so let's have the virtual environment ready. Okay, so let's see if it print a hi for us. Yeah, hi PyCharm. Okay, so everything is prepared. So now let's install. So just see here that we are working in a virtual environment. So basically we are working on a copy of a basic Python. Okay, so we are not working in a global, in whole Python that is running on our PC. So we are using a copy of the Python. So let's install that library. Paste. Let me read about how to use it. Older version, and then overview. We had this installation, short introduction. That's what we need. So we use import serial. So let's remove these lines. Import serial. Then serial name. Just copy these lines. Serial codes. Okay, so this is the line that we start with. Remove this part. we want to open comport 5, so it's rewrite comp5. We just make sure that the, yeah, so here we disconnect it. We write a hi for now. Let's just try to see if it connects or not. Yeah, so comp5 is connected. Now what should we do? Let's go back to here. We can increase the speed here. So let's increase it to maximum speed that we can get. But it's not the maximum. It's maximum for UART application. But here let's just stick to this number. Okay. What is this? Be careful when. Let's specify timeout. Oh, sorry. Timeout 1, 2. Probably it's in seconds. So after 2 seconds, if we didn't receive anything, we just close the serial port. Then read line. Okay. Let's search PiSerial example. There should be an easy way to read. So for now, just let's try to see if we are receiving anything when we run this line of code. So let's put the breakpoint here. Let's try. Yeah, we received something. So what we received is user rx data buffer. Okay, we received the hi. Okay, so you can see we received hi. That's good. So we are able to sending something. So this is the function for sending, but we should be able to receive as well. So let's see how we should do that. Probably we should use some thread. Okay, so we should, while true, should wait for the read line. Okay, let's see. Ser.readline, and then what? Okay, then the response will come out in the here, and then let's print response and just f response. Let's see. So how was this formatting stuff in Python? I forgot that. Python format. Okay. Oh, sorry. It was like this. I think it was in the old version was like that. So now it's like this. So I write response equal to something, and then I write format. Then here I write response. Okay. Is our code running? No. Okay. You should be able. Yeah. we receive welcome. Okay, so this is the easy method to send and receive something from the COM port. But the problem here we have is that we are basically stuck here. So if we don't receive anything, we'll stay here forever. That's not what we want. So what we can do is that we can write a function, let's say receive handler. Then in that one, we write this line of code. So it stayed there. I'm just trying to imagine what will happen. So it also write this. Okay. We don't close the serial. Okay. So we have this receive handler. So now we should make a new thread. And this thread basically is a, let's imagine that you have another program running in parallel to your code. So nothing will stop your code from running. So it will run in a separate, let's say, context, and it will always stay there for the for receiving a new data. So we don't need to wait on that line in our code. And we will receive, basically we will, if we put a while here, while true, so now we should be able to receive like whatever we send. Okay, let's see the thread, Python thread. Okay, I think it's this one, and we need to import threading. Threading target is receive handler. Sorry, should come here. This one should go here to make it bit receive handler, and we don't need any argument to pass. So that's it, I think. And let's just, I think we should start it somewhere. Yeah. So it would be t equal to this, and then t.start, and that's it, I think. So we should be able to receive whatever. Let's try. Yeah. So okay, here we can see that it timeout basically every 2 seconds because we specify the timeout. So this function is running forever, and it will wait for line to read, and then if it reads, it will return it to us. Otherwise, it will return nothing. So we just here we write if response was how was this? I forget that. I think it was like that. No. Yeah. If response was nothing, then don't print it. So if the response was not this, then print it. Okay. So let's stop and run again. So we received the welcome. It is timeouting now. Oh, why we are receiving it again? So let's debug the program. Okay, we received the first one, which is okay. Okay, now we should not receive anything. Oh, okay. So it's a array of bytes. So if we get the length for this, or len, yeah, len. If the len was 0, was bigger than 0, then it means that we receive something. Welcome. Okay. Oh. So what is the len here? Len response. Let's see. Okay, 9 makes sense because we received welcome. And then, oh, sorry, I should forget. I forgot to remove that equal. So if it was bigger than 1, so it means that we received something. So we can see here, we have the response and nothing else. So you see, basically we send something, we send hi, and we receive something. So that's all you need for working with the Python code here. Okay, so I think that's it for this part. Okay, so until here, we managed to run the code on the microcontroller. We managed to connect it to the Python to receive the information on our PC. But now let's do something fun with it, okay? So I want to make a timer for myself to measure my productivity. So I want a timer to basically count here, and then I want it to count only when I'm working, okay? So basically, let's just imagine this. There is a timer here. When I'm working, it's counting, for example, the seconds that I'm working. As soon as I stop working, I want to press a button on my board and the timer will stop. Okay, so I want to push the button to stop the timer, and then I want to push it again to start the timer. So basically, it's like a timer connected to a button on the STM32 board. Okay, so let's see how we can implement this. We just keep these codes for now. Okay, so what we want here? Let's think. Let's search for Python chronometer, something like that. Chronometer. What is this? Okay, so let's see. Yeah, we want a stopwatch basically. Yeah, so let's see what they are doing. Let's search for stopwatch, Python. Yeah, this would be a nice thing. We just want a demonstration for now, so it would be a nice thing. Let's put it here, while true. Okay, so let's run this line of code to see what happened. What happened? Why it's not running? Let's test it. Test. Oh, we are stopping somewhere. So most probably we stopped here, maybe. Let's see. Let's see. Yeah, we are running on the main thread. So Python threading. Let's see what we made. TS start. Runs on main thread. So what is happening here? Oh, I think should remove this because it's basically calling the function. Oh yeah. Okay. So now it's it's counting the time for us. So we want it to count only when we press the button. Okay. So this is the counter that we wanted. So let's change the code to this. Here, press the button to start the stopwatch. Okay, so we'll stay here, and then let's write a function def stopwatch handler, then while true, if counting was true, then count it first. Okay, so we need to remove this. Then we need to have the counting variable here, false. Then we need to say global count. Okay. So while true, if the counting was true, let's put it after the 1 second. So after 1 second passed, if the counting was true, so just increase it and print it. Okay. So let's run it, and we need to run it in another thread. Okay. So let's remove this part. Let's copy this, add it here. Okay, so here we need another thread to run that stopwatch handler T2. Okay, so it's waiting for the waiting for starting the stopwatch. So just let's manually change the counting to true and see if it works or not. Local variable before assignment. Okay, we need to move this here because this is the function that we needed. Otherwise we can write global day, global hour, global minute and second. Let's run it. Okay, yeah, it's working. So now simply we need to write a code in our STM32 to just send a start when we press the button. Okay, so let's write a function here, hal GPIO read pin. So it was, I think, do we have it here? The push button. No. Let's see what pin was that one. Pin view. Yeah, it was B1. Okay, so let's go back to the code. No, this is the old code. We want it. We want the main.c. So B1, B1 pin. If user pushed it, we will transmit B1 for now. If yeah, we transmit B1, then we need to debounce it as well. So our delay then while this then so we are debouncing it as well. Let's skip this line of code here for now. It's okay, we don't need to be worried about this. Let's run. Okay, so it's counting, but it doesn't matter for now. Just let's try the button. Yeah, we are receiving B1, okay? But what is these extra things that we are receiving? B1, B. So let's stop it here. Stop. Let's stop it inside this. Okay, it's B1. Fine. Okay, what is this? Response. We receive 9 bytes. P1. I'm just thinking. Let's search for, sorry, for serial, PiSerial, read line, extra. What can be the problem? Why we are receiving 9 bytes and what are the bytes? So one is 0000 S B1 /R /N. Oh, I think I found that. So I think we are sending B1, but so we are sending B1, but we are we forgot to set the length. So if we set it right, so it's like 4 bytes here, it should be okay. Let's try. Let's run the code. Okay, so the count, let's also do the count, like set the counting to false to stop printing extra information. Okay, press B1, B1, yeah, okay. So we can see B1 is going through the system, and here we just write a code if response was equal. So let's search for bytes to string in Python. Okay, so bytes ABCD decode UTF-8. UTF-8 is very common coding, but you need to use the encoding data is actually in. Okay, so str response, because the data that we are receiving is in bytes, so we want it in string, so we want a conversion here, and this is the indicator for the byte. So it's saying it received a byte of these values, so we just need to convert that. So we write str response dot decode, and the format that we are using is UTF-8. Okay, if you're using, for example, I don't know, Chinese or Arabic, I mean, if you're sending that data, which is rarely happen, you should use UTF-16 or UTF-32. Okay, so we are using UTF-8, and then here let's just compare this response. If the response was B1, then yeah, that's it. If the response was B1, we have global counting here. We just write counting is equal to not counting. Is it okay? In Python, toggle boolean Python to see if there is a way to do that. Okay, we should write not counting. Okay, so let's check the lines. So we read the lines, we don't need that. Then if it was more than 1 byte, more than like 0, if we received something, we decode that to the string, and then we check the string. If it was B1, then counting will toggle. Okay, so it should work. Let's try B1. No, it's not working, probably because this line is not working properly. Let's see. Okay, str response. Oh, okay. Okay. I forgot to change this and this. Okay, now it should be okay. So run. Step over is F8 here. F8. Okay, so now it's working. Let's try the code. Okay. Bing. Okay, it's working. So yeah. So when I'm working, I will press this button. As soon as I got distracted, I use this button to stop the timer. So it will basically measure it for me, how much I'm working with the while. Like, I think it would be useful to measure your productivity using this. So it's a useful project. Yeah, that's it. So that's it for this week session, and hopefully see you in the next one using the accelerometer. Bye bye.